Hi, my name's Javier. I go to school at the University of Illinois at Urbana-Champaign. Originally, I was born in Valencia, Spain, and now I'm studying here PhD in aerospace engineering. So I first came to NASA in the summer of 2014. Since then, I have come every single summer, and my research for my PhD is also related to all that work that I've been doing here at NASA since 2014. In particular, I'm working on a project called ATTRACTOR that aims to advance trust and trustworthiness in unmanned systems like drones or cars without a driver, things like that. And I work on two things. I make sure that the paths that are generated for those unmanned vehicles, mostly aircraft in my case, are safe. And also I work on how those aircraft need to talk to each other, to understand each other, to coordinate properly, and to achieve a success in a mission. In particular, we're focusing in search and rescue missions. My research that I do has application to all these fields, and I try to make all those autonomous systems and trustworthy. So I design the algorithms, but I try to guarantee that those algorithms are safe to fly, that all that information that the drone is receiving from the different sensors, like lidar information, camera information, acceleration, attitude of the drone, all those things are passed through all the algorithms that need them in a safe manner, and that information and the uncertainty that comes with that information is used safely to guarantee that this drone is not going to hit anyone, that the drone is not going to run out of battery. So I check all those constraints and try to make things safer. So imagine we have a search and rescue mission where a hiker is lost in the middle of a mountain, and we don't really know where the hiker is, but we more or less know the area that we need to search. So we have a bunch of assets, so a bunch of unmanned aerial systems that are distributed in different locations. So we're going to leverage all those assets that are going to take off, search the area in a coordinated manner so they don't overlap, they don't hit with each other, and of course, things don't work always as expected. So maybe in the middle of the mission, the drones need to recompute the path, or a human has received another piece of information, so it needs to convey to the drones that, oh, this area is of specific importance. So the drones may be able to recompute those paths, still talk to each other, make sure the new flight plan is safe, continue the mission, and sort of adapt to all these unexpected events that could happen during the execution of a search and rescue mission. Once the drones have searched the area, hopefully they have found the hiker, and they can communicate all the information they have collected to the rescue team, and the rescue team will use that information to rescue the hiker. Once those drones are finished with that part of the mission, they will return to their sort of base stations, and that's sort of the end for me. But of course, the rescue team has a lot of work ahead.